Welcome back, everyone. This is me, Mohammad Vamik, and we will be continuing with our class for computer sciences. First of all, I hope that what I have already been teaching you in the first and second week is already clear to you. And some of you told me that this is basically the area that we have already covered. So I believe and I'm expecting that if I have reinforced this area again to all of you, I believe that now it is crystal clear and you don't have any queries, you don't have any difficulties as well, because I'm assuming that all of you have completed the activity as far as I can see your names. And you need to remember one thing right here is that as per the class activities that I am receiving, you will be received dojo marks, dojo points for that. So if you are working with me and completing all of the activities on time, that means that you will be definitely be rewarded for that. So I highly appreciate all those students that are working along with me. Just in case if you are a slow learner or just in case if you are having any difficulty, please don't hesitate to ask. You can send me an email. You can send me a comment on IMS Teams. I try my level best that the moment I receive the email or the message, I respond to you guys back again. So I'm here to help. Classroom is basically a place where all of us learn, all of us are here. And I believe that if you're making mistakes, that is not the problem. That is your real success. But if you are not making any mistake, this is the problem. The point is that if you're making mistakes, that means that you are learning. And I believe that classroom is definitely a place where all of us combines together. We learn, we study, we enjoy with each other. So uh, we will be continuing our lesson for this third week, and I'm here to help. I'm here to support. If you need anything, please don't hesitate at all. So for today's class, we will be discussing the topic that is trace tables. That is basically a part of your algorithms and problem solving. So I know that some of you might be having an idea of what are trace tables, and some of you already might have or might not have an idea that what are basically trace tables, but that really doesn't matter. Like, for example, if I just gave you a word, trace table, what does it comes into your mind, right? Like, for example, if it is asked to me that I need to understand this term trace table, I can expect it, right? Like when I was in my primary grades, learning, when I was learning to study in the grade one, two, three, or in the grades lower than that, I remember that as a kid or as a child, I was given a trace book, and into that book, how I or all of us learn to make sentences or to write sentences or to write alphabets. I used to have a trace table. I used to have a trace book with me, and what it was basically like for example, if it's my name, right? Like Sir Vamik is my name. So what mostly happens into that trace books, like that I was given some sort of connecting dots that if I just trace on all of them, it basically makes that sentence trace table. So the word trace table basically means that when you are tracing onto some of the alphabets, I'm just giving you an idea, or when you're checking those values. So this is what we are going to discuss in today's class. That is your 7.7 IGCSE Computer Sciences Trace Tables, and in today's class, what we are going to discuss is basically how can we uh, complete a trace table to document a dry run of an algorithm. Dry run of an algorithm. I hope that all of you do understand that the word dry run. Dry run basically means when you have a piece of software and you are trying to test that software by giving different values. So when you are giving a set of different values, you are testing them, you are running it, it means that this is a dry run of your algorithm. So, what are we going to discuss here? We are going to discuss here that what is variables, what are outputs, and what are user prompts. So, trace table is what we are going to discuss in today's class, and the keywords for today's class are going to be variable, user input, output, dry run, or another trace table. Another keyword I can give you is a trace table. So even before starting the lecture with all of you, I just want all of you to just go along with these keywords, or if you have the appropriate definition of all of these keywords, please type these into my MS Teams as a comment so that we can discuss this, right? Like even before starting the chapter, I'm just reviewing these with you. So I'm giving you 5 minutes for this, right? So what you need to do is that you need to give me everything that comes into your mind when I'm discussing these words. If you know any one of them, you can write it. If you know all of them, you can write it as well. So just share your ideas. Just like, yeah, like that. This is basically the area where we brainstorm, we think, and then as a teacher, I conclude your thinking. I conclude your thoughts. So that's how we develop our teaching and learning. So basically, your time starts now, and I hope you are going to give me good answers. I hope that all of you are done with your thought process, and we can begin our class. So, so far for the last class, what we have basically discussed is regarding the test data types. I have already discussed with you that what is a normal test data, what is an extreme test data, what is a boundary test data, and what is abnormal test data. And I can see the all of your activities answers as well. So I think that we are good to go. So even before starting the trace tables, first of all, I just want to give you an overview so that your concepts are totally clear when it comes to a trace table. So let's start it. So basically, when I am referring to a trace table, I can say that a trace table is a structure. A trace table is a structure to help you to follow an algorithm. A trace table is a structure to help you follow an algorithm. That means that when you are following an algorithm, so you must be having a structure so that where you can write down your values, or maybe you can note down or check that how it is actually working. So if it is basically a trace table, that means that it provides you with a structure, so that that structure is going to help you when you are following an algorithm. For example, to find an error or to work out what an algorithm does. That means that if you are recognizing a part of an error, or if you want to check that how some of the elements or how some of the items are working, so you can definitely use a trace table. Like, right, like for example, I asked you to have a piece of code, a piece of code for calculating the students' marks. So how are you going to test that? How are you going to check that? You are going to check it when you are going to add those marks of the students, right? Because the software is going to be tested if it is generating the correct output or not, and this can only be done when you have added those marks into that, right? So when you are adding those marks and you are just checking that if it is calculating the correct percentage or not, or if it is calculating the correct sum of number or not, so perhaps which is the workplace or where you can check if all of them being calculated correctly or not, the place is to be known as a trace table. Because in a trace table you can actually work on an algorithm that how it is going to work. So as per the keyword, I know that some of the answers you have already generated. So what is a trace table? A trace table is basically a structure to complete when walking through an algorithm manually. That means that if you are working onto an algorithm manually, or if you are going on to that, so you can actually see that there may be having some of the values that are being changed, and at the same time you will be having the values that are not changed. So it is basically a table. It is basically a place where you can check all of these values. In a trace table, each statement in an algorithm is written manually. That means that you are writing each and every value manually, and then all of these values and variables are written into that order. Right, like each column in this table is designed to have one variable. So there can be columns for any output to be returned, or we can use the user prompts. Or let's discuss this with an example that is right here. So I'm going to uh, discuss this example right with you guys. So for example, this example states that to create a trace table, first of all, you need to identify all of the variables in an algorithm. So variables, what are basically variables? Can anyone of you define me that what are variables? Why are variables used? What is the use of them? I can also say that basically a variable is basically a name given to any, you can say, a field or a category into your program, and it basically has values that can be changed throughout your program. Throughout your program. So for example, if you have a software or if you have a program, and that program is basically for that program is basically that you are calculating the percentage of all students in a class. By percentage, I means their academic percentage as to which level of percentage, either if it's higher or low. So what are going to be the name of the variables into this program, or then the name of the values that can be changed? So I can say that if this is a program, so I'm going to have the variables, right? Like variables, you can also say that variables are also known as placeholders, or you can also say that variables are data holders. They have the value that can be changed. So for example, your variables in this case is going to be student name, first variable. Then you are going to have your student marks, second variable. Then you are going to have the number of subjects that you have into your program, and definitely those number of subjects can vary, like, right, like for example, it could be either like physics, it could be either like math, or it could be either like computer science. But now what you have to notice right here is that all of these are variables, right? All of these are data placeholder values. All of these are values that can be inputted into the computer, and they can be changed as well. For example, if I have 5 students into my class, when it comes to the first student, I'm going to have all of the details of the first student. For example, the name is Rayan, the marks, student marks, the total marks are, for example, 56, physics has 10, maths has 10, computer has something around 35. Just giving you an example. So this is for the first student. When you are going to go on to the second student, for example, the second student name is Mr. Muhammad. So you can see some of the values right here as well. Then again, it is going to become for the third student. So I'm just trying to teach you right here that variables have values that keeps on changing it again and again. You need to focus on one thing right here, is that only these are the values that are being changing again and again, because a variable only has values that can be changed throughout your program. They hold these values, but important thing is that the name of the variable is not going to be changed. I'm writing it right here as well, that only the values will be changed because these are variables. And I'm also writing it right here, names will never be changed. So till here, I should be clear that what is a trace table? A trace table is basically a structure that helps you to go through with your programs. It is used to check for errors. It is used to check for mistakes. And when it comes to a trace table, you have your variables, right? So in this example, we can see that to create a trace table, you need to identify all of the variables in an algorithm. Okay, we are done getting this. each variable should have its own column in the trace table. So that means that if these are the number of variables, all of these must be having a different column where you can store all of their values. So there should be also an output column if the program will output any data or a string. So if it's generating an output, for example, if it's adding a sum of values, so there should be an area where we should be adding the sum of that as well. So for example, right here is given you as an example that trace the following algorithms with the input values 1 and 3. So you can see that right here I am giving a pseudo code, and that pseudo code is regarding the first thing I need to do right here is that input number 1. Input number 1 means that the value, the variable is the number 1, and any value that comes in number 1 needs to be input here. I'm repeating it back again. I hope that it's clear to all of you. There should be an output column if the program will output any data or a string. For example, trace the following algorithm with input values 1 and 3. With input values 1 and 3 means, for example, if you want to input number 1, now any value that is going to comes under the number 1, it is going to be input. The second part says that input the value of number 2. Then it says that if your number 1 is greater than number 2, then what you need to do is that you need to output the number, else you need to output the second number and if. So you can see that there are two variables and there is output as well. So if I just share it with you, you can see that uh, every variable has also basically a column as well. As you can see right here, this is the column for number 1, this is the column for number 2, this is the column for number 3. So for example, let's take an example. If I want to input the value of number 1, let it be the value of number 1 is 10. Input the value of number 2, let it be the value of number 2 is 20. Now if number 1 is greater than number 20, then output number 1. That means if this number 1 is greater than number 2, that means if 10 is greater than 20, then what you need to do is that you need to output number 1. And in this case, this is basically a false statement. Else, what I need to do, if this is not the case, then I need to output number 2. That means 20 is going to be written right here. So I hope that this example is clear to all of you. So again, here you can see that I have one another example right here. Input number 1, input number 2. If number 1 is greater than number 2, then output this. So you can see that first of all, it says that input number 1. Input number 1 means that I have added the value of number 1. Input number 2 means that I need to value the value of number 2. Then I have the if statement. I have the comparison part. That means that if this value is greater than that, what I need to do, I need to output number 2. Right? So this is your first example. I hope that it is clear to all of you. Now, for the second area, uh, let's discuss this. Okay, so following with the working example of trace table, I have a question right here on the left hand side of the question. you can basically see that this is a trace table. This is how it is used to look. And at the same time, you can also conclude that basically it is a structure of an algorithm. And on the right hand side, you can see that this is what it is to be named as basically a trace table, or you can say maybe a flowchart. So you can see that all of the variables of this trace table are given the values right here. So if I start solving this table, first of all, I need to start it from right here. This is where I'm going to start it. So this one goes like 1. Then you can see that you can see that you okay, so you can see that right here you are given some of the values, and those values are A is 0, B is 0, and C is 100. So the first thing you need to do right here is that you need to enter the values here. From here, I can see the value A is 0, B is 0, 100, C is 100. So what I'm going to do right here is that I'm going to add those values. So again, from this box, the value of A is 0, the value of B is 0, the value of C is 100. Then the table says in the third part that what I need to do is that I need to input the value for X, right? I need to input the value for X, and the value for the X's are given to me right here. As you can see that this is basically my test data, and the first value that is given right here is 9. So what I'm going to do right here is I'm going to add the value of X, and the value of X is definitely a 9. I have added the value right here as well. Now, in the fourth part, it says that is the value of X greater than B. Now, what is the value of X? The value of X is 9. Is it greater than the value of B? What is the value of B? Right now, the value of B is 0. If it is yes, then what you need to do is that you need to store the value of X into the value of 9. This expression says that if this statement is true, then you need to perform the following task. And the following task, what is this? This. Now, you need to understand that whenever you have this arrow sign, this arrow sign basically stands for assigning the values. Now, this is saying that whatever the value you have in X, you need to assign it to B. So the value that is in X, the value that is in X, this is the value of 9. It has to be assigned to B, right? Okay. The value of X is 9, and the value has to be assigned to B. I have done that. This is done. This is done. This is done. This is done. This is also done. Now, it says that is the value of X greater than C? Now the value of X is 9, and is it, oh sorry, is it less than C? What is the value of C? The value of C right here is 100. So yes, this is the condition. This condition is true because the value of X, which is 9, is less than 100. So if this is the case, then what you need to do, you need to perform this expression. This expression says that whatever the value is X, it has to be added into the value of C. So the value of X is 9, and it has to be added into the value of C. So this is it. I'm done with this part as well. Now it says that in the end, what you need to do is that you need to have the value of A, but the value of A is generated by adding 1 into the last value of A. The last value of A is 0, and if I add 0 plus 1, it results in 1. So this is also done. Now it says that is the value of A greater than 10 is 1. Oh, sorry, less than 10 is this is the case. Yes, this is the case. A is lesser, 10 is greater. So that means now I need to move on back to this. So this is what we need to do in this. So the first loop is correct. So let me just remove this area. Let me clean it up this for you. Now we are going to run the second test. The results are right in front of you on the right hand side. So now the second value is input x. I need to input any value that is in the table x. So the 9 is already taken. Now I need to work on 7. I'm starting from right here because this is where the arrow took me. Input x. So the value of x is 7. The value of x is 7. Now it says that is x greater than b? The value is 7. Is 7 greater than b? The value of b is 9. Yes, it is. Then what you need to do is that you need to give the value of x into b. The value of x into b. Oh wait. This is not the condition. I'm not going to go here because 7 is greater and this is small. So I'm going on to the no part. I'm repeating it back again for you. Now I need to take the value of x. The value of x is now 7. I entered here 7. Now it says is the value of x greater than b? Is the value 7 greater than b? The value in b is 9. No, this is not the case. No. I'm going to go below. Is the value of x greater than c? The value of x is 7. If the value less than c, what is the value in c? This is 9. Is this the condition? Yes, the condition is true. And now what I need to do is that I need to give the value of x into c. The value of x is 7. So this is going to be entered right here. And again, what I need to do is that now I need to add another value into a. So this is going to be my 2. So is the value of a less than less than 10? Now I'm having 2. This means that I need to go forward. Yes. So the second trial is also complete as well. Now what I need to do is that I need to take the third value. So the third value is right in front of you. Now the third value is 3. I'm going to take the value of 3. Now let me just name it all for you. This is my first part. This is my second part. This is my third part. This is my fourth part. This is my fifth part. This is my sixth part. This is my seventh part. Now I'm going to solve it real quick. Now I have taken the value of 3 right here. Now it says that is the in the second part, if the value of x is greater than b, The value of x is 3. Is 3 greater than the value whatever it is in your B part? Is 3 greater than 9? No. That means this is going to come onto the stage 4. This is going to be skipped. Stage 4 says that is the value of x. The value of x is 3. Is it less than the value in 7? Yes, this is true. The value is less than 7. Then what you need to do is that the value that is in x, you need to send it to C. The value that is in x, you need to send it to C. And at last, what you need to do is that you need to enter a value of a plus 1. So a plus 1 is 3. Now again, I'm going to go on to the top of that. I'm just going step by step for each and every one of you. I know that some of you knows how to solve it, but at the same time, I also want to work on the students who have difficulties in solving them. So the third part is done. Now I'm going to move on to the next value. Then the 9 is done, 7 is done, 3 is done. Now I'm going to take the value of 12. So let's check it. I have taken the value of 12. Now it says that is the value of x is 12 greater than b. The value of b is 9. Is 12 greater than 9? Yes, this is the case. Then what you need to do is that you need to enter the value of x into b. The value of x is 12. You need to enter 12 right here. I have done that. Now you need to go on, is the x value less than c? The value of x is 12. Is it less than whatever the value is in c? The last value is 3. No, this is a wrong condition. I cannot agree to that. So I'm moving on to this. So what you need to do is now you need to add a plus 1. So a plus 1 becomes 4. So this is done for 12. Now I have also done that. So now I need to go for the fifth trial. And for the fifth trial, what I need to do is that I need to take the value of 6. So I'm going to write here 6. Now again, I'm going to start right here. Is the value of x greater than b? The value of 6 greater than b? Is this the case? No, this is not the case. I'm going to come right here. Is the value of x less than c? The value of x less than c. So is this statement correct or not? This statement is still incorrect, and I'm going to come right here. So this is going to be noted down as 5. And again, I'm going to go on top of that. This is done. I'm going on to take the next value, which is going to be your 4. So this is going to be my sixth trial. Uh, Let me remove this. Now for the sixth trial, I have taken the value 4. The value of x is 4. Now, what I'm doing is that is x greater than b? Is 4 greater than whatever the value is in b? The value in b is 12. No, this is not the case. Then is your x less than c? Is your value of x less than the value of c? The value of c is 3. So is the statement correct or not? This statement is still incorrect. And now I need to move on to this part. This says 6. So this is also done. Now I am going to take the next value, which is 15. So this is going to be my seventh loop. I have taken the value of 15. Now, it says that if the value of 15 greater than the value of in B. Is this the case? Yes, it is. Then what you need to do is that you need to enter the value of X into B. So the value of X into B, the value of X into B is 15. Then is the value of X less than C? The value of X is 15 is less than C. The value of C is 3. This side is greater. Again, this is not a correct statement. So again, I'm just going to add 1 here and I'm going to move on to the next stage because still the value of A is less than 10. I need to have that exact value equivalent to 10, then I'm going to have the correct answer. So again, 7 is done, 15 is also done. Now, what I'm going to do is that I'm going to take the value of 2 and again, I'm going to do the same area that I have done right here. So I'm just quickly putting up the value so that you can do it on your own. 2, 2, 8. Then just after 2, I have the value of 8, no value, and then 10, which is perhaps the last value. So let me work along with you with the last value. I have done 2 and 8 for myself. So let's check on the value that is in fifth. So I have taken the value of 5 here. Now, again, let's see that if the value of X is greater than B, the value of X is 5. Is it greater than B? The last value in B is 15. Is this the case? No, it is not. Then what you need to do is the value of X is less than C. Whatever the value is C is the value of X is 5. And is it less than your C? The value C is 2. So still this statement is not correct. So with the 5, what I'm going to type, I'm going to enter here 10. Now you can see that the value of A is 10 here. Now if I just take this value, or if this says that if A is less than 10, now the value of A is 10. So this statement is being true. So I'm not going to go on to the 11th part. Now what I'm going to do at last, I'm going to output B and C. So the output that I'm going to generate right here is supposed to be my last value, which is going to be B and C. So for the B and C part, you are going to write 15 and 2 is going to be your last value. And this is how it stops here. And this is how the question is completely solved. This is your final answer. So I hope that this question is clear to you. Trace tables are clear to you. You can see that how all of this trace table I have worked on. I started with stage 1. I added all the values and I started the comparison. So I hope that this is clear to each and all of you. You know, what is the easiest way or what is the best way to solve these types of questions? You can see that how I am myself solving it. I am literally just writing each and every expression again, then I am writing all those values again, and then I am calculating the results into my trace table. So that's how you generate your accurate answer. So if you have any queries, please send out to me. Again, right with this question, I'm sending you one another question and right into my lecture. I'm adding another important area that is to be known as an extended learning. So for students who are complete with all of my work early, I have added another section that is to be noted as an extended learning. So the question is, sir, I have done my activities, and even if I complete my extended work or extended activity, uh, what makes the difference, right? The point is that if you are going to complete all of my work on time, and if you are also going to complete all of the extended works, you will be awarded with the dojo points, the rewards with that. So I just want all of you to give your best shot. I want all of you to work with your best, and even if you can complete the extended area as well. You need to remember that everything you do in my class and every work or every extra mile or every question you ask, that makes me really happy, and that also gives you some sort of marks or points based on that, on your behavior or how you are replying or responding to me into the class. So if you are acting energetically, and if you are participating actively into my class, that means that you will definitely be rewarded something for that. So I hope it's clear to you. I hope that my lecture is clear to you. If you have any queries, please post to me. And I will also be sharing with you the class activity and the extended activity. So if you are done with that, you can carry on with the next activity. So thank you so much, everyone. Thank you so much for today's class. I'll see you soon. Take care.